All right, let's talk about a subject that, let's be honest, can seem a little scary at first, trigonometry. But here's what I want you to do. Just for a second, forget all those formulas. Instead, think of it as this really beautiful logical system for figuring out how angles and relationships work. It's all about patterns you see, and we're going to break them all down together. So, what's our game plan? Well, we're going to start at the very beginning with the core definitions. Can't build a house without a foundation, right? Then we'll see why we have to go beyond the triangle. After that, we'll open up the formula toolbox, which is full of awesome shortcuts. Then we'll learn how to work backwards. And finally, we'll pull it all together to really master the patterns that make everything just click. Everything in the entire world of trigonometry, all of it, is built on one simple, super powerful shape, the right angle triangle. This is ground zero, so let's make sure we've got this part down cold. Okay, this right here, this is the absolute heart of it. So you take any angle in a right angle triangle, we'll just call it theta. The incredible thing is, the ratios between its side lengths are always the same. We just gave those ratios some names: sine, cosine, and tangent. And the easiest way to remember which is that classic mnemonic, so, co, toa. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. That's it, that's the entire foundation. But, right angle triangles have their limits. I mean, what happens when we're dealing with angles that are bigger than 90 degrees, or even negative angles? For that, we're going to need a bigger map. So here's the problem, right? A triangle can't have an angle bigger than 90 degrees. Not a right angle triangle, anyway. So how in the world do you find the sine of 120 degrees? Or the cosine of, say, negative 30? The triangle model just kind of falls apart. We need something more powerful. And that more powerful tool is the unit circle. This is brilliant. Instead of thinking about side lengths, we now think of sine and cosine as the y and x coordinates of a point on a circle. That one little shift lets us define them for any angle you can imagine. And to keep track of whether the values are positive or negative, we use a simple trick for the four quadrants, A, S, T, C. Just remember, all silver teacups going counterclockwise. It tells you which function is positive in each quadrant. All, then sine, then tangent, and finally cosine. Okay, now that we've got the fundamentals down for any angle, this is where the fun really begins. We're going to open up the toolbox and look at the tools that let you take apart, simplify, and solve even the most complex trig problems. Now, you're about to see a bunch of formulas, but don't panic. Please don't think of this as stuff you have to memorize. Think of it more like a set of Lego bricks. You don't memorize each brick, right? You just learn what each one does. And with these, you can build or break down pretty much any problem you come across. And guess what? It all starts with a formula you probably already know, the Pythagorean theorem. Seriously, the number one most important identity in all of trigonometry, sine squared plus cosine squared equals 1, that's just Pythagoras on the unit circle. It's the master key. And from that one single idea, we can unlock all these other helpful identities you see here. They're amazing shortcuts. So what if you need the sine of, say, 75 degrees? That's not one of the standard ones. Well, you can't just add the sine of 45 and the sine of 30. It doesn't work that way. Instead, you use these compound angle formulas to break 75 degrees down into 45 plus 30, angles you do know. They're absolutely essential. Oh, and a quick heads up, watch out for the cosine formula. See how the sine flips? That gets people all the time. Now, a super common situation is when you need to deal with a double angle, or 2 alpha. These are your go-to shortcuts for that. And here's a really slick pro move. If you just substitute the letter t for the tangent of the original angle, you can rewrite the whole thing using just t. It's a neat trick that can turn a really messy trigonometry equation into a simple algebra problem. This really just shows how much of trigonometry is about spotting patterns. I mean, look at this. On the left, you've got these little shortcuts for adding sines and cosines, and you can remember them with phrases like s plus s equals 2sc. And on the right, for triple angles, you don't need to do some crazy long derivation. You can just remember number patterns like 343 for the sine formula. It's all about working smarter, not harder. Okay, so we've gotten really good at going from an angle to a ratio. But what if you have the ratio and you need to find the angle? Well, for that, we have to learn how to work in reverse. So here's the thing with going backwards. If I ask you, what angle has a sine of 0.5? Well, the answer could be 30 degrees or 150 degrees or 390 degrees. It goes on forever. For a calculator to give us just one reliable answer, Everyone had to agree on a standard set of output values. And that's what this table is showing you. It's the official, single answer your calculator is programmed to give every single time. You know, one of the things that trips people up with inverse functions is dealing with negative numbers. But it turns out there's a really simple pattern. All the functions fall into one of two families. For the family on the left, it's super easy. The negative sign just pops right out to the front. Done. For the family on the right, you just have to do one extra step. You adjust by subtracting the positive version from pi, or 180 degrees. Once you know which family a function is in, you know exactly what to do. Wow, okay, so we've gone from a simple triangle all the way to inverse functions. Now, let's bring it all home and see how mastering just a few key patterns is the real secret to unlocking all of trigonometry. And this is really what it all boils down to. True mastery isn't about brute force memorizing every single formula. It's about really understanding the core patterns, the factorization shortcuts, the triple angle number tricks, the ASTC rule for quadrants, and those two families for inverse functions. If you get the logic behind these four boxes, you've pretty much got the whole system figured out. The goal is to master the patterns, not just the numbers. So I'll leave you with this question. We've been talking about triangles and circles this whole time, but what we've really been describing are cycles and waves and repetition. Now that you can see these patterns, where else do they show up in the world? Think about sound waves, the electricity in your